Okay, done, I think. Okay, look, I don't usually record my course, so let me know if, we'll see if it doesn't work or works. All right, so we're going to start with the sine rule and the cosine rule. Now, some of you guys might have done this before, so the sine rule and cosine rule I think is pretty straightforward. There's nothing too hard about them. As long as you remember the formulas and when to use the formulas, it's pretty easy. The main thing that you want to get to is, so with the sine rule, let's start off with the sine rule because the sine rule I think is a bit more simple compared to the other formulas. Now, just before we get into the sine and cosine rule, I just want to remind you guys that SOHCAHTOA, which is what you did in year 9, right? This only applies to right-angled trigonometry. Right, so right-angled trigonometry just means that it only applies to right-angled triangles only, right? So the way I like to see it is that if I see any triangle with this right angle symbol, then I think SOHCAHTOA. Yeah. If you don't see that right angle symbol, then you want to use formulas such as sine rule or the cosine rule, which is what we're going to talk about today. Pretty straightforward. I might have actually gone through this with some of you guys already, but it is good to revise it again. And for you guys that haven't done it, I hope that you guys can see that it's pretty easy once you get the hang of it. It might be a bit difficult at first, but once you apply it 3 or 4 times yourself, you're going to find that it's fairly straightforward. So just a reminder that SOHCAHTOA we only use for right angle trigonometry. As soon as you see a right angle, then you think SOHCAHTOA. Now, for non-right angle trigonometry, so that means that any triangle that doesn't have a right angled, you are going to use a formula called the sine rule or the cosine rule. Yeah, so you either want to use the sine rule or the cosine rule, depending on what you're trying to find. Yeah, so the sine rule and the cosine rule can be used to find either angles or sides, or the same thing with the cosine rule, you can find angles or sides. Yeah. Now there is another formula that you guys learned last week, which is the area of a triangle, right? So the area of a triangle, I don't need to say what it finds. It finds you the area. So if you want to find what the area is, right? If you want to find what the area of a triangle is, then you use the area of a triangle formula. Now, the sine rule, right? The sine rule is given by this formula here. So I'm going to write it down here. It is going to be A over sine A. So let me just write this properly. It should be more like this. A over sine A equals B over sine B. Right, so it's pretty easy, like in the way that, you know, you got capital A over sine A, capital B over sine B. Very straightforward to remember. Now, the way that you might see it in your textbook or the way that your teacher might present it to you is they'll also have the C equals sine C part. Now, I don't really teach that because it's useless. You don't need to worry about that C over sine C stuff. There's most of the times when we're solving an equation, we only want one equal sign line. This kind of expression at the end is kind of redundant, so I would really forget about it. Don't worry about it too much. The main thing that you guys want to remember is that it's A over sine A equals B over sine B. The cosine rule is going to be given by this formula here that I'm going to write down now. I'll write down red as well. Now, this should look familiar to you guys, right? C squared equals A squared plus B squared, right? C squared equals A squared plus B squared is the Pythagorean identity, right? So if you remember that part, you already remembered half of the formula. Because a lot of people, when they first see the cosine rule formula, they find it a bit daunting to remember the whole thing. But just remember, it's a lot like the Pythagorean identity. And then it's just got one extra bit at the end where you go minus 2ab cos C. Okay, so that's the only difference, is that this is pretty much the Pythagorean identity here, right? This is Pythagoras, which you should remember. You guys are all in advance, right? So you should remember Pythagoras by now. That's the Pythagoras identity. And then all you have to do is remember this extra term of negative 2ab cos C. And then we also have the area of a triangle, which you guys talked about last week, which is half area equals to, let me just fix that up. Area equals half AB sine C. half AB sine C. Yeah, I'll go through the area of a triangle again later just to helpfully remind you guys how to use it. And remember, there's a certain condition on A and B. They have to be the two sides that make the angle that you're using. That's the rule that most people tend to forget. But besides that, let's start off with the sine rule. The sine rule is a bit more straightforward compared to the cosine rule. So let's get started. So the sine rule. Let's use blue here. So let's start off with the sine rule. So the sine rule, I'm going to write it down again. You guys don't need to worry too much about writing this, okay? I will send you the PDF of what I'm writing to you guys in the chat at the end of the lesson. So don't worry too much about writing it down. You guys should be able to, I will send it to you guys and then you guys can just review it. So the sine rule is given by this formula here, A over, let me fix that up again. Oh, you can use A, it doesn't matter. A over sine capital A equals B over sine capital B. Right, I just want to make sure that there's a reason why I have a lowercase a and a capital A. They are going to be different in the way that capital A is not the same as little a, and capital B is not the same thing as little b. So they're not the same number, okay? That's why we have a lowercase and an uppercase. I'm going to explain why one's a lowercase, one's uppercase. So you want to use this rule when, so you got to identify, you want to mainly use this rule when you have two sides and two angles. So two sides and two angles. Okay, so when you see two sides and two angles, you want to use this formula. So two sides and two angles with one of them being unknown. So one of these is unknown. One of these is unknown. So it could be like one of the sides is unknown. So you have two sides, two labeled sides, and you have two angles that are labeled, and one of these is unknown. Or you can use two angles, or one of the angles is unknown, where the two sides are labeled, and then you got one angle that is unlabeled. So just to give you an example of that, so for example, if we had this triangle here, so let's say we had this triangle here, there is no right angle symbol. So in my head, I'm already thinking, okay, I probably want to use the sine rule or the cosine rule here. So let's say that this is 52 degrees, and then we'll say this is 46 degrees. We'll say that this is 12 and this is 14. Yeah, actually, we'll call this X. We'll call this X, sorry. So we'll call this X. Yeah, so see here we have two sides and two angles. So when you see two sides and two angles, right, what you want to think is you want to think sine rule, okay? The cosine rule, which we're going to learn a bit after this, is three sides and one angle. So here you see two sides and two angles, you should be thinking cosine rule once you get the hang of it. Because a lot of times people ask me, how do I know when to use the sine rule, when to use the cosine rule? Just count how many sides you have, count how many angles you have, and see what you're trying to find. So the way we apply the sine rule is you got to go back and think about your opposite sides and opposite angles. So if I go back to right angle trigonometry, so I'm just going to do a slight tangent here. If you remember that if this was theta, our opposite side is opposite the angle, right? So the way we want to use the sine rule here is that you got to identify the angle which is opposite the side. So you see this X is opposite the 46 degrees. That's the first thing you want to identify. Which side is opposite which angle? This 52 degrees is opposite to this side, right? Now, another way that you can think about it if you have a hard time understanding this is to go, this 46 degrees is made by, if I highlight it, this line and this line. So this 46 degree angle is made by these two lines. So it's the side that doesn't make the 46, yeah? So in this 52 degree angle, this 52 degree angle is made by, if I get rid of these highlights, this 52 degree angle is made from this and this side. So this 12 doesn't make the angle, so that's going to be the opposite side. Yeah, that's another way you can think about it. After enough practice, you can clearly see which one's the opposite side with the opposite angle, and then you're going to match those up. Now, generally, when we're solving these type of questions, we like to have our unknowns in the numerator. So we say, so we got X over sine 46. Now, by drawing these lines, it's very obvious that, you know, A and B represent lengths. Yeah, I'm going to write here A and B represent lengths. And capital A and capital B represents angles. Yeah. So what you want to do is whenever you're using sine, cos, or tan, sine, cos, and tan are used in conjunction with an angle. You never sine, cos, and tan and a side length. Yeah. Think about when you did SOHCAHTOA. When you're using sine theta, cos theta, tan theta, you were always using it with an angle. You never used it with a side. So you never signed a side or cos the side or tan the side. What you would always do is you would sine an angle, cos an angle, or tan an angle. So here we're going to do the same thing, is that we're saying that x over sine 46, which is the opposite side with opposite angle, is equals to opposite side with opposite angle. Yeah, so we got 12 with sine 52. So by drawing these lines, it's pretty obvious to see which one pairs up with which. So we got x over sine 46. So this side over sine 46 equals 12 over sine 52. Yeah, so all we're doing here is we're matching opposite side with that opposite angle. And the reason why we do that is because this is the formula for the sine rule, right? Is that it's saying that the opposite side over the sine of the opposite angle is equals to the side length, the other side length over the sine of the opposite angle. So what we want to do now is we want to solve for x. So we just solve this like an equation. So we bring, this is a divide by sine 46. Treat the sine 46 as one number. So the way you can think about it is sine 46, if you put it into your calculator, is going to give you some number. So if that number, to bring that over, we multiply. Yeah. So that'll be 12 over sine 52 times by sine 46. Then what we want to do now is that we just plug that into our calculator. So we plug that into our calculator. I'll quickly do it. 12 divided by sine 52 times by sine 46. 12 divided by sine 52 by sine 46. That's going to be 10.95. So we've got 10.95. Let's say these are centimeters. Or don't forget your units. Put centimeters there. Okay, so pretty straightforward. If you have any questions, let me know. Does anyone have any questions regarding this? No, it doesn't look like it. So what I'll do is I'll keep going through a couple more just to see if you guys get the hang of it, and then I'll give you guys a couple questions to try and do. But as you can see, the sine rule is pretty straightforward. But yeah, let's just keep going through a couple more examples. For now, we're just going to look at finding side lengths and we'll talk about finding angles later. So let's say we have a different. Yes.
In the top formula, when you write it at the top, you put capital A and B at the top. But in the second, when you're figuring out the question, you put capital A and B at the bottom.
Yeah, it doesn't really matter, to be honest, as long as they're different.
Doesn't?
Yeah.
Okay.
Yeah, it doesn't really matter too much. They will change it all the time. It's arbitrary. It's just a letter. So what I mean by that is like, if you're solving, so when I say like in maths, when we say something is arbitrary, what that means, it doesn't matter what the letter is, you still get the same answer. Whether it's a capital X or little x, it doesn't matter. It's like if you're solving x plus 5 equals 12, x is equals to 7, right? If you're solving y plus 5 equals 12, y is equals to 7. The question gives you the exact same answer. The letter doesn't matter because we say that this is arbitrary. So what that means is that it doesn't matter what the letter actually is. It doesn't change the answer, right? Same thing here. You'll see in some textbooks they'll change it to little a, capital A. It doesn't really matter too much. The answers still remain the same anyway. So they're arbitrary. Look, you could write E over sine capital E if you want. It's just that in all textbooks they just write A over sine A equals B over sine B. You could write F over sine F, capital F, if you wanted to. It doesn't really matter what it is. The formula is still used the exact same way. You match opposite side with opposite angle. All right, so that's a good question. Let's do another one. So let's say we got this triangle here. So let's say that this is 130 degrees. That's X. That's 15 degrees. And then we'll say that this is 10. So you see here, I've got two sides, two angles. So I see two sides, two angles. In my head, I'm already thinking, all right, well, this has to be a sine rule, right? So, okay, so we match this 130 with this x, and we match this 15 degrees with the 10. Yeah, you got to have the opposite angle with the opposite side. So then I like to always write down the formula before I start a question. Now, the reason why I always write down the formula before I start a question is because if you write it down enough times, you will start to remember the formula. Yeah, it's always good to write down the formula before you start a question, because even if you get the question wrong, let's say you did the working out wrong, you will still get a mark for at least identifying which formula is right to use. Yeah, so it's a good habit to get into, writing down the formula before you do each question, and it allows you to help you memorize the formula as well. So a over sine A equals b over sine B. So let's do this. So you always generally want the x as the first expression. It doesn't really matter too much, but it's just easier to have x as the first expression. So we get x over sine 130, right? Because x goes with sine 130 because x is opposite the 130 degrees. And then we got b, which is 10 all over sine 15. Yeah, same thing here. All we do, sine 130, bring it across, treat it as a number. So this will be 10 over sine 15 times by sine 130. So all you have to do now is just plug that into your calculator. You don't do this by hand, obviously, because it'd be way too hard. So we do 10 divided by sine 15 times by sine 130. And we get 29.59. If we round that to 2 decimal places, I'll just say 29.6 centimeters. Let's just assume these are all in centimeters. Don't forget your units. Yeah, I think for the people that have had me, I always emphasize, you got to make sure you put down your units. If you don't put down your units, you will lose a mark. And you don't want to lose a mark for something that you know how to do. So 29.6 centimeters, and that looks about right, because one way that you can use to check your answers is just using a bit of common sense. This is 10. You can see this line is clearly much longer than this line. It's 10 centimeters. So to me, it looks like 29.6 does seem like a right answer. Yeah. Even though this isn't to scale, you can kind of just look at it and tell whether it looks right or not. That's something that you should be kind of doing, is just making sure whether your answers look right, because a lot of the times you can't check your answers in most of these questions that you're doing. But you can just sometimes just eyeball it and just go, yeah, it kind of looks right. All right, so let's do a couple more. Let's say we have a triangle that looks like something like this. So we got a very similar triangle, just kind of like flipped 180. Let's say this is 103 degrees. This is, let's not use 15 again. Let's say this is 22. Let's say this is 23 centimeters, and we're trying to find out what this side here is. So I see here there are two labeled sides, two labeled angles again. So therefore I want to use sine rule. Then what you want to do is match the opposite side with the opposite angle. So this angle goes with this side, and this angle goes with this side. Yeah. So you always want the side on top in general. So I'm going to write down the formula again. So a over sine A equals b over sine B. Right. So a here is going to be usually the unknown. We usually let the unknown be a over sine 22, because we can see that this side matches with this angle. And then we got b here, which is 23 over sine 103. Yeah. Then what you want to do here is bring the sine 22 across by multiplying. And then what you want to do there is basically plug that into your calculator and then do it. Like, as I said, a lot of this is just mostly calculator work. There's nothing too hard about this. Once you get good enough at this, you could probably do this mostly all in your head, and then just plug it into your calculator. So this will be 8.84 centimeters if I round it to 2 decimal places. Okay, so that's how you do those ones. Now there is one type of question that I want to make sure you know how to do. So this one is definitely important, because I'll tell you now, right? I'll tell you now. These type of questions, if you get this in an actual exam, you're quite lucky, right? These ones are pretty straightforward. If you get these type of questions, they're very straightforward, right? If you get one, good on you. You should get 100% in it. Now, the type of questions that are a bit harder would be something like this, and I'll explain why this one's a bit trickier. So let's say we have something like this. Let's say, that's 72 degrees. That's 23 degrees. And then we have, this is x, and this is 15. Now I'm looking at this and I see two sides, two angles. Yeah, I see two sides, two angles, and then I go, well, to me, it looks like a sine rule question. And I would say, yeah, you're right. It is definitely a sine rule question, two sides, two angles. Then I go and say, okay, well, let's try and match up the sides with the angles. So I got this goes with this. And then I go, the 72 goes with this 73 degrees. The opposite side would be this length here, right? But we don't know what that length is. So that is where the main problems are, where a lot of students get stuck and they go, well, I don't know what to do from here because I've got a 72, but I've also got another unknown. This equation is used for solving one unknown. I can't do something if I have more than one unknown in general. So how do I go about fixing this issue? Well, there's one way you can fix this issue. This is why I mentioned that this is going to be important, which is that you see this 15. This 15's opposite angle is going to be over here. This angle here, right? This angle. I'm going to try color it in. I know pink's a bad color here because it looks a lot like the red. But that angle there is going to match with the 15. And the way we can find that angle is by using the angle sum of a triangle. Remember that the angle sum of a triangle, the angle sum, you write that again, I wrote triangle sum rather than angle sum. So the angle sum of a triangle, you guys should remember this by now, is always 180 degrees. So to find out what that angle is, all I have to do is 180 minus 23 minus 72. And that gives you 95, so it should be 85 degrees. I don't know, which equals 85 degrees. Yeah, so that's 85 degrees. So that angle there is going to be 85 degrees. So now you can apply the sine rule because now you have an opposite side, that 15 with the angle of 85, and this 23 degrees with the side of x. So now let's use the formula. So let's write down the formula again. A over sine A equals B over sine B. So we got A, which is x, all over sine 23 equals B. Now B here is going to be 15. So remember your A and your B here, the numerators that have no signs, they are going to refer to the lengths. Whereas the things that are attached with the signs are going to be the angles. So 15 over sine 85, because you can see that this 15, the opposite angle is the 85. Then we just do what we normally do, is we can just bring this sine 23 across by multiplying it across. And then what we can do is we just plug that into our calculator. So let's do that. 15 divided by sine 85 times by sine 23. And that'll be 5.88. So 5.88 centimeters. Okay. So 5.8 centimeters looks good to me. That's how you do it. This is the type of question where I would highly recommend that you remember. This is the type of exam style question that you'll most likely get. They most likely won't ask you simple ones like this, but you'll most likely highly get questions like this. Yeah, so I'm gonna put like a bubble around this, a horrible bubble. But yeah, so that I would highly recommend you really memorize that one, because that's the type of one that catches a lot of people off guard where they have no idea how to do that, right? So what you want to do here is you want to use the angle sum of a triangle to find out what this angle here is so that you can use the sine rule. So it requires an additional step. So when you're finding a side, it's pretty straightforward, nothing too hard. Now let's, what I'm going to do is I'm just going to try to give you guys a couple of questions to do. I know that you guys used a book. Just give me a second. So I'll give you guys a couple of questions to try. So I know you guys should have book 1. Now I'm going to put it up anyway, so it's up to you whether You can look at book 1. So I'm just grabbing this from book 1 of your non-right angle trick. And I just want you guys can either look at my screen or look at the PDF that Sam sent you already. If this is too small, I'm sorry, there's not much I can do about it. Try to make it as big as possible. I want you guys to just quickly do these 4 questions and see how you go. So I'll give you guys about 5 minutes to do these 4 questions, maybe possibly even 6-7 minutes. So I'll give you guys about 5 minutes to do these 4 questions, and then I'll go through them just to make sure that you guys understand them. So give those 4 questions a try. If you have any questions, please let me know. You can round up to 2 decimal places. 2 decimal places is fine.
Oh, David?
Yeah.
I got question 4 and question 9.
You got question 4 and question 9?
Yeah.
As in you've done them or you've got a question about them?
No, I finished them.
Finish them? Yeah, do 5 and 10 as well.
Alright. David?
Yeah.
Oh, I'm done.
Okay. I'll give everyone just an extra 1 minute just to make sure. All right, I think I've given you guys more than enough time to do this. So I'll just quickly go through these 4 questions just to make sure we understand how to do this. So let's see. So with this one, first identify, you got 2 sides to angle, so you want to use the sine rule here. Identify the side with the angle. So this 105 goes with this 400 and this 48 goes with the x. Yeah. All right, so what we have is let's write down the formula. A over sine A equals B over sine B. So remember the numerator here just refers to the side length. So we got x, we always want to use x first if we can. X over sine 48, yeah? Opposite side with opposite angle, and then we got 300 with the opposite angle, which is sine 105. All we do is bring the sine 48 across by multiplying through, and then what we have is, let me quickly do that. So we got 300 divided by sine 105 times by sine 48. 230.80, so x equals 230.81. If we do it to 2 decimal places, let's just assume that this is all in centimeters. So 230.81. If anyone gets anything different, please let me know. I am only human, so I will make mistakes from time to time. So that's question 4. Now question 5, just match opposite side and opposite angle first. So you got 2 goes with x. This 3 degrees goes with 24. So then let's go. So we got A over sine A. I'm going to write down the formula. As I said, I always write down the formula before I do any question. It just makes it easier to see. So I always want x first. X goes with sine 2. And then B is going to be 24. So 24 over sine 3 degrees. And then what you want to do here is, as usual, bring the sine 2 across, sorry, and then just do that on your calculator. And then we should get 24 divided by sine 3 times by sine 2. And we had 16.00. So it will just be 16 centimeters. Let's just assume all these in centimeters. All right, next one. Same idea. We got 6 degrees goes with this side. Well, that looks like a problem already. And then we got 8 degrees goes with this side, right? We want to avoid doing anything with any unknown side. So let's ignore this side. And then we got this x here goes with this angle. And as I said, we can find out what this angle is by using the angle sum of a triangle. This angle here is going to equal to 180 because the angle sum of a triangle is always 180. Minus 6 minus 8. That's minus 14. That'll be 166 degrees. So now we can use the sine rule. So we got A over sine A equals B over sine B. So what we have is let's say, x over sine 166 because the opposite angle to x is 166. And B here is 13 over sine 8. Then what we want to do is we want to bring that sine 166 across. So 13 over sine 8 times by sine 166. Put that into our calculators. Sine 8 times by sine 160, which is equal to 31.95 centimeters. So hopefully you guys can see by now that this is fairly repetitive. It's pretty straightforward, nothing too hard. All right, so what I see is that this 115 goes with this angle here. We don't know what this angle is, but we can clearly see that's going to be 40 if we use the angle sum of a triangle. And then that 80 goes with that x. We're not going to use this matching one because it doesn't matter, okay? We don't have the sine length for that, so we can't use that. So we got x over sine 80 is equals to 115 length over sine the angle. Yeah, always remember sine the angle. Then what we want to do is bring the 80 across. So 115 all over sine 40 times by sine 80. Okay, so 115 divided by sine 140 times by sine 80 is going to equal to 176.19. Yeah, there you go. Nothing too hard. Pretty straightforward, I think. Yeah.
I got a different answer for 9.
Yeah, 9. What did you get?
I got 22.6. That's rounded.
Okay. Let me double check. What did you do?
I did 13 over sine 8 times sine 166.
Okay, I must have put it wrong into my calculator then. So 13 divided by sine 8 times by sine 166. Oh, you're right. I think I did something wrong on my calculator. So it's 22.6. You round 2 decimal places. Is that what you got, Sam?
Yeah.
Yeah, okay, cool. Thanks for that. All right, 22.6, perfect. Yeah, as I said, I make mistakes as well. Yeah, so looks like I had the right working out. So that's why it's important to write down the formula, right? If you write down your working out as well, you would have gotten at least a mark for that, even though I've clearly done something wrong on my calculator. So I've pressed the wrong button, which can happen. So just writing down the working out. Sometimes if you're lucky, the marker might still give you 4 marks for it. Because if they see the right working out and you've gotten the wrong answer, what that tells them is that, okay, you know how to do it. It's just you probably put something wrong in your calculator. All right. So that's the sine rule for finding a side. Now we got to learn how to use it to find an angle. So to find an angle, what we got to do is we're going to use the exact same rule. So this is all for finding a side. Yeah, I'm going to write just like a little subheading here where we want to use it for finding an angle. All right. Sine rule to find an angle. Sine rule to find angle. So using the sine rule to find an angle, it's pretty straightforward. What you want to do here is it might be easier for some people to invert the formula. So what I mean by invert the formula is that you want reciprocal both sides. Yeah, the reason we can do that is if you remember back to equations, whatever you do to one side, you do to the other side. So what we're going to do is we're going to flip the fraction on both sides. If we go back and take a look at the formula that we initially used, I've written here multiple times, a over sine A over sine B. When you're using it to find angle, what you want to do is you want to flip the formula. Okay, it will just make your working out a lot easier by flipping it first. Okay, so the way you want to do that is, let's say we got a triangle, right? It still follows the same principle, opposite side with the opposite angle with opposite side. So still the same thing. Let's say we got 30 degrees here. We got unknown, so let's call that theta. And then let's say that we have, this is 12 and this is 15. Okay, and we want to find out what theta is. So remember that when you're signing something, you're always signing an angle. You're never signing a side. All right, well, I'm going to keep repeating that because it's a very common mistake that people make. So we always want the unknown first. So this will be sine theta all over the opposite angle, opposite side, which is 12. I should have drawn this first before we started this. So when sine theta all over 12 equals sine 30 all over 15. Okay. So now what you want to do here is you want to bring the 12 across. You bring the 12 across by multiplying, because the inverse of divide is to multiply. 30 over 15 times by 12. All right, now here's where you have to do one additional step. So what I'm going to do is I'm just going to evaluate what this is in your calculator. In our calculator, so sine 30 divided by 15 times 12, and we get 0.4. Okay, now if you go back to your SOHCAHTOA, what you want to do is if you want to bring the sine across, you have to do sine inverse. The way we do that on our calculator is we press shift sine and 0.4. Yeah, so shift sine 0.4. To bring the sine across, you got to do the inverse. And in this case, we call that sine inverse. And theta here will equal to 23.58 degrees. 23.58 degrees. Yeah. Remember, this is an angle. An angle is measured in degrees. So make sure you write your answers in degrees. If you don't, we'll lose a mark as well. So that's how you use it to find angle. Pretty much the same thing. All you got to do is you just got to flip it, and then you got one extra step here where you have to do the sine inverse. Yeah, because remember that when you want to bring a sine over to the other side, you got to do the opposite, and the opposite being here, to bring the sine over to the other side, you got to do sine inverse. Let's take a look at another question. So let's say we got something like this. So we have this is theta, and then we'll say that this is 10 degrees. I know there's a horribly drawn triangle, but let's say this is 10 and this is x. So let's draw opposite sides of the opposite angles. So this 10 degrees goes with this side, and then this theta goes with this side here. So we're gonna do, we always do sine theta first. We always want our unknown numerator. Sine theta, sorry, we should have a length for this. It shouldn't be x. So let's say that is 40. So sine theta all over 40 is equals to sine 10 all over 10. So what you want to do now is you want to bring the 40 across. So sine 10 all over 10 times by 40. Let's multiply. Let's do that calculation in our calculators. So sine 10 divided by 10, multiply that by 40, we get 0.69. So sine theta is equal to 0.69. Like with every other equation, our goal here is to find what theta is. We've got to isolate the theta. So we've got to bring this sine over, and then we just do sine inverse 0.69. Okay, now shift sine enter, and we get 44 degrees if we round this to the nearest degree. So you get 43.99, but just to make it our lives a bit easier, we'll just say that's 44 degrees. Okay. Now, you have to be very careful with this type of question here. Okay, now this type of question shows up in exams as well. 44 here is clearly an acute angle. And I hope you guys remember what an acute angle is. Remember that an acute angle is an angle between 0 to 90. If you look at this actual angle itself, right, this angle here is an obtuse angle, right? It passes the 90 degree. It passes the 90 degree mark. You can clearly see that it's going to be greater than 90 degrees. When you have a question like this, where you can clearly see it's an obtuse angle, but your answer is an acute angle, what you actually need to do is that you need to do 180 minus your answer. So theta, the actual answer, is going to be 180 minus 44, which is equals to 136 degrees. So whenever you see that is the actual answer, not the 44. If you left out 44, you would have missed out on one mark. You've got every other mark before that, but the actual answer is going to be 136 degrees because you can clearly see that theta is obtuse. Okay. Now, one thing that I want to mention is that this formula will always give you an acute angle. Always give you an acute angle. Right? So if you need an obtuse angle, you get your answer and then you do 180 minus that. Shouldn't you also minus the 10? That is a good question. No, you do not. Because the reason being is, so if I draw this out, let me try to draw this out a bit better for you. So we have 10 degrees here. What you found here essentially, that 44 degrees, what you found is you've technically found this angle here. This is the 44 degrees that you found, right? Now, because you want to find out what the obtuse angle here is, you want to just do 180 minus 44. Does that make sense? Because what you've really found is you've really found this part here, which is outside the triangle. Now, if we took away the 10, what that means is you're trying to find the angle sum of a triangle. Yeah. So this 44 is kind of an external angle. But because this is an external angle, what you want to do is you want to do 180 minus 44 to get what this angle here is, which is 136. Okay? So just to go back to my previous point is that this will always give you an acute angle. If you need an obtuse angle, just do 180 minus theta, which is the angle that you calculate. Yeah, so this is the angle that you've calculated. Angle that you've calculated. Yeah, so we don't need to minus the 10 here. If that doesn't make sense, send me another message and I can go through that again. But whenever you see an obtuse angle, just remember that, you know, your answer will always be acute when you're using the formula. Because it's always going to be acute, you just do 180 minus the answer that you got, and that will give you the obtuse angle. Let's look at another question. So let's say we have this triangle like this. We'll have like, this is 60 degrees. This is 52 degrees. Sorry, we'll call that theta. And then we'll say that is 12. Maybe not. Maybe we'll say that this is 12 and this is 12. Okay. So let's try and do this. So what we got to do is I'm going to write down the formula. So sine theta. So we're going to do sine A over A is equals to sine B over B. Right. We're going to match opposite sides of the opposite angle. So this angle goes with this side and this angle goes with this side. So I always draw the line so that it's very obvious to me which ones I'm doing together. So it'll be sine theta. You always want your theta on the numerator, your unknown in the numerator. It just makes our calculation a bit easier. So sine theta over 12 is equals to, well then let's look at sine 60 all over 12. Yeah, because remember you're sining the angle. Then what we do is we bring the 12 across. So 12 times by sine 60 on 12. Right, if you do that on your calculator, what you should get is 12 times sine 60 divided by 12. You get 0.866. Sine theta is equal to 0.866. And then what we do is if we shift sine that, so we sine inverse it, we get theta equals 60 degrees. So here we get theta equals 60 degrees. Now, if you were clever enough, you would have gotten this answer without doing this whole calculation. The reason being is that these two numbers are the same. If these two numbers are the same, well then that means that this is an isosceles triangle, at least an isosceles triangle. If this is an isosceles triangle, then these two angles have to be the same, because remember the property that the base angles of isosceles triangles are equal. Right, so you can even do this. You can do questions like this. If you can see that this is clearly an isosceles triangle, you can skip all this step and just write theta equals 60 and get your full marks. Right, if you can make little observations like that, it will make your life a lot easier. So here we got theta equals 60, right? But if you don't see it, right, and sometimes it's a bit hard to see, and I wouldn't blame you if you don't see it, right? Then just doing this is fine. It won't take too long anyway. But especially in the exam situation, if you can notice little tricks and little patterns like that, it will save you some time for the harder questions. So here we got theta equals 60. Okay, let's look at another one. So let's say we've got something like, I know, something like this. We'll try to draw that a bit bigger. So let's say this is 83 degrees, and this is, we'll call this theta. And then let's say that this is 15, and we'll say that this is 22. Okay. All right. So what we want to do is let's write down our formula first. Is that this is sine A over A equals sine B over B. Then what you want to do is you want to match angle with side, angle with side. Yeah. And then what's going to happen there is that you're going to have sine 83. Sorry, we always want the unknown first. So we're going to say sine theta all over 15 is equals to sine 83 all over 22, right? We always want the unknown first if we can. It just makes looking at it much easier. So what we're going to do is bring the sine 15 across, sine 83 all over 22 times by 15. Then, you know, we put that into our calculators. Whoops, I wrote 2 thetas there. We'll put that into our calculator. So sine 83 divided by 22 times by 15. We get 0.67, 0.6767, and so on and so forth. And then all I do is I just press shift, sign, answer, and I get 42.59 degrees. Yeah, so if we round 2 decimal places, which is going to be the default, if a question doesn't say how many decimal places you should round it to, just use 2. 2 is pretty much the default amount of decimal places that you should be rounding to. So hopefully, as I said, these questions are fairly straightforward. It's pretty much the same application. The only thing that you need to remember is that you're going to flip the formula. Okay. One thing that I would definitely mention, like what I said about the previous examples, is that these 3 questions that we've done here, very easy. If you get them, you're cheering. This last question here, the second question here, where you have to do 180 minus the answer that you get, right? That's the type of a question I would see in an exam, right? There are 2 ways they usually go through this. Is that usually they'll show you an obtuse angle that's clearly obtuse, or another way they'll do it is they'll say that given theta is obtuse. So if the question says given theta is obtuse, then you need to do this, yeah? But if the question doesn't say anything, well then you can leave it as an acute. All right, so what I'm going to do is same thing here. I'm just going to put up a couple of questions for you guys to do just to give it a try. Yeah, so as I said, this is from exercise. This will be from exercise 2 from the non-right angle booklet. From the non-right angle booklet, I'll put these 4 up. So questions 3, 4, 8, and 9. If I can have you guys quickly do those 4 questions, I'll give you guys 5 minutes to do those again, and then I'll quickly go through it, and then we'll look at the cosine rule. All right. Hopefully that's enough time for you guys to go through these questions. Let's quickly do them. So match opposite sides, opposite angles first. So this one goes with that one goes with that one. So what we have here is that we have sine theta all over. I'm just going to go through these a bit quicker so that we have time to go through the cosine rule. Sine theta over 44.5 equals sine 63 all over 61. Don't forget you're always signing an angle. Then what you want to do here is you want to bring the 44.5 across. So sine 63 over 61 times by 44.5. And then what you want to do is put that to your calculator and then shift sign it. So I will quickly do that. Sine 63 divided by 61 times by 44.5. So we get 40.54 degrees. All right, so that's that one done. Now let's do this one. So we got this one goes with that one goes with that. So we have sine theta over 196 equals sine 17 all over 251. Same thing, sine 17 all over 251 times by 196. Then what you want to do is plug this into your calculator and then sine inverse it. So sine 17 divided by 25 times by 196 is equals to that. Oh, okay, this one seems interesting. Oh, that should be 251. Whoops. Sine 17 divided by 251. That will be 13.20. 13.20. Should be in degrees as well. This one goes with this one goes with this one. So we have sine theta all over 185. I'll do this in a different color actually. So we have this angle goes with this side, this angle goes with this side. So we got sine theta all over 185 equals sine 105 all over 300. Okay, so we'll bring the 185 across. So sine theta equals sine 105 all over 300 times by 185. I'm going to do this in my calculator and then find out what theta is. So sine 105 divided by 300 times by 185. Shift sign. We get 36.56 degrees. This one, theta is an obtuse angle, very important. Theta is an obtuse angle here. So theta goes with that one goes with that. So what we have here is we have, see this in green. So we have sine theta, sorry, it's a bit bigger. Sine theta all over 85 is equals to sine 8 all over 12. Sine theta is equals to sine 8 on 12 times by 85. Theta is going to equal to 12 times by 85, which is that 80.34 degrees. Now don't forget that theta is an obtuse angle. This is an acute angle. So when you have that case, what you have to do is you have to do 180 minus the answer that you got, and that is going to be your actual answer. And that should give you 99.76 degrees. Actually, it should be 66 degrees. So 79.66 degrees there. Okay. If you got anything different, let me know. But besides that, those should be the answers. All right. Doesn't seem like anyone's saying they got anything different, so I'll move on. All right. Now let's talk about the cosine rule in the last 25 minutes that we have together. So the cosine rule, as I mentioned earlier, right, it looks a lot like Pythagoras' theorem. So if you can remember that, you can remember this part of the formula, which is Pythagoras' theorem, then all you got to remember is just this additional part here. Yeah. So c squared equals a squared plus c plus b squared minus 2ab cos c. Technically, this should be a little c, should be a lowercase c, and that's an uppercase c. So these c's are not the same value. Yeah, I'm just going to put a note here that is lowercase, and this is uppercase. Yeah, so they are different. Just keep that in mind. They're not the same number. All right, so when do we use the cosine rule? So I said that we use the sine rule when there is two sides and two angles. So we use the cosine rule when there are three sides and one angle. So that's when we use the cosine rule, right? With one of them being unknown. One of them being unknown. Okay? So the sine rule, I will say this again, is two sides, two angles with one of them unknown. The cosine rule is three sides, one angle with one of them being unknown. It could be the angle's unknown or one of the sides is unknown. So very easy. This is like, I would say 90% this is just calculator work. I know it looks a bit daunting, but it's just mostly calculator work. So let's say we got this triangle here. Let's say that this is X, this is 10, this is 12, and this is 15 degrees. Yeah. So we got to find what X is. Now, your unknown side, right? So the thing that you have to remember here, and I'm sure you guys did this when you're doing the area of the triangle, is that if you remember from the area of a triangle, if you use this formula, half AB sine C, I'm sure Sam would have told you that A and B have to be the two sides that make the angle. Yeah. So what you want to do here is you want to make sure that the way I do this before I do any question is I label my sides A, B, and C. This is A, this is B, and this is C. A and B always have to be the two sides that make the angle that you're given, right? That angle, we call that the included angle. It's very important that you remember that, right? Is that A and B are always going to be the two sides that make the angle. So what we say here is that A and B has to make the included angle. Yeah. So the way we can use this formula now is that now we've replaced the C with X. So this will be X squared. And A here is 10. So it'll be 10 squared. Plus B. B here is 12. So it'll be 12 squared. Minus 2 bracket. A is 10. I can clearly see that. B is 12. I can clearly see that. Cos. Now, capital C means cos the angle. So cos 15. Yeah. Now, your C, another way that you can remember this is that this angle should always be opposite the side that you're given. The side that you're trying to find. This angle should always be, let me rephrase that, this angle should always be opposite the side that you're trying to find. Yeah? So X squared equals 10 squared plus 12 squared minus 2 times 10 times 12 equals 15. You might look at that, you go, what the hell is going on? All you have to do is just plug that into your calculator. Now, before you plug that into your calculator, I would recommend you trying to solve as much of this in your head before you put it into the calculator, because when you're putting too many buttons into your calculator, what happens is that you can generally make a mistake. So I know that 10 squared is 100. I know that 12 squared is 144. 2 times 10 is 20. 20 times 12 is 240. Right, I'll do that first. And then 100 plus 144 is 244 minus 240 cos 15. I like to solve as much as I can because sometimes when you put too many things in your calculator, you're bound to press the wrong button. So I just do as much as I can. So 244 minus 240 cos 45. Sorry, cos 15, not 45. And you'll get 12.17. 18. You round 2 decimal places. So 12.18 centimeters. Yeah. So the most important thing here is that this C should always be the unknown side, right? This C should always be the side that you're trying to find. And the A and the B, it doesn't matter if you call this one A, this one B, or this one B, this one A, or this is B, A or B, and this is A or B, as long as A or B are the two sides that make the angle. So it's very, very important. These are the two sides that make the angle. Yeah, that is where a lot of people go wrong when they're using this formula. I would say most of this is pretty straightforward. The only thing that people get wrong is not knowing which side is A, B, and C. Right? Once you know which side is A, B, and C, it's pretty self-explanatory how to do this. So let's say we got this triangle here.
I have a question.
Yeah.
Aren't you meant to square root in that last section?
Yes, you are, actually. I forgot about that. You are very correct. All right, we're supposed to square root that. My bad. So square root 12.18. I can't believe I forgot that, actually. Yep, 12.18, and then we get 3.49. Thank you. 3.49 centimeters. Good call. Very, very good. All right, so yeah, we'll just square it because we have that in squared terms. So we have to square it to get rid of the square. All right, let's look at the next one. So we have, let's say this is 120 degrees. This is 15. No, actually, we're going to say that's not 15. We're going to call that X, and we're going to call this 6, and we're going to call this 7. So I'm going to write down the formula. As I said, I always write down the formula first because I know this is a bit of a hard formula to remember, so I just keep writing it until I memorize it, right? I don't have a formula sheet in front of me. I actually do this because I've done this many times that I can remember it. So C squared. C is always going to be the unknown. So in this case, it'll be X squared. What I like to do is when I'm first starting off, I'll label that C, I'll label that A, and I'll label that B, just so it's easier for me to substitute in. Remember, A and B are always going to be the two sides that make the angle. Yeah, the two sides that make the angle. So we've got X squared equals A, which is 6 squared, plus 7 squared, minus 2 times 6 times 7 times by cos 120. Then what you want to do is you just want to plug that all into your calculator. I'm just going to quickly 636 plus 49 minus 12. 12 times 7 is just 84 cos 120. And then what we're going to do is 36 plus 49 is 70, 85. So it'll be 85 minus 84 cos 120. And that will be 127. And then what you want to do is, I'm not going to forget this time, which is square root it. Square root the number, because you have a square, the opposite of a square is a square root. And that will be 11.27 centimeters. Okay, it's a very straight formula to use, to be completely honest with you. There's nothing too hard about this. The only thing that I'm going to mention it again, is that your unknown side should always be the subject, and A and B always have to be the two sides that make the angle. You cannot choose A and B to be just two random sides on the triangle. There's a specific way to choose them, and make sure you do follow that criteria when you're choosing that. A and B have to be the two sides that make the angle. All right, let's look at another one. So let's say we've got a triangle that looks something like this. This is 93 degrees. This is 12. Let's put that. And then we will say that we want to find out what this is. Let's call that X. Now, remember what this dash means. This dash means they're the same length. So this is going to be 12 as well. Yeah. So what we do now is we have three sides, one angle. That tells me it's a cosine rule question. These two sides make the angle. So I know that this is going to be A, this is going to be B, and whatever's left over is my C. Now it's just for me to write the formula. C squared equals A squared plus B squared minus 2AB cos C. So I know C is here replaced with X, so it'll be X squared. A here will be 12 squared. Now I'm just going to start doing this. 12 squared is 144. B squared is going to be 144 as well. Minus 2 times 12 times 12, which is 144, times by cos 93. Right, and that is going to be 288 minus 288 cos 93. So plug that into our calculator. 288 minus 288 cos 93. We get 303.07. And then what we're going to do is we're going to square root that. 303.07. Square root answer, and we get 17.41 centimeters. Okay, and that's how we use the cosine rule to find a side. There's actually no trick to this. Like, for example, if we go back and look at the sine rule, I showed you some like kind of exam questions where, you know, what they do is they make you use the angle sum of a triangle, or they use the obtuse angle trick where, you know, you have to do 180 minus. But besides that, like when you go back and look at these ones don't usually tend to have a trick to them. So they're generally, you just use the formula and then you get the answer. So yeah, so these ones there's nothing too bad about this. It's just recognizing when to use the sine rule, when to use the cosine rule is important. Sine rule, two sides, two angles. Cosine rule, three sides, one angle. Now let's look at using the cosine rule. So using cosine rule to find an angle. Now, you need to understand how this formula is derived. Okay. Now, if you look at this cosine rule to find the side, if you're looking at this cosine rule to find the side, right? It's c squared equals a squared plus b. C is clearly a length here, right? So what we need to do here is I'm going to write down this formula again. So we have c squared equals a squared plus b squared minus 2ab cos c. So we're going to say that this is used to find a side. So to make it find an angle, what we're going to do is we're going to have to rearrange this and make cos c the subject, because c is the angle, right? This is the angle. Yeah. So let's rearrange this. So there's a couple ways. So the easiest way to do this is what I'm going to do is I'm going to bring, I'm going to write this again. C squared equals a squared plus b squared minus 2ab cos c. Is that I'm going to bring this minus 2ab cos c over to this side. And then what I'm going to do is I'm going to bring this c squared over to this side. Okay. So this will be positive 2ab cos c, because if you bring a negative over, it becomes a positive, and you got a squared plus b squared minus c squared. You will need to know how to derive this formula. Then this is 2ab times cos c. So what we can do is we can say a squared plus b squared minus c squared all over 2ab. Right? And that is the formula that you want to use to find the angle. Okay? Same restrictions apply, is that you can't just choose A and B randomly. A and B have to be the two sides that make the angle. That make the included angle. Yeah, we call it the included angle. Included angle. Okay, so I'll quickly go through a couple of examples of this. So let's say we got a triangle that looks something like this. Let's say this is unknown, so we'll call this theta. We got this is 10, this is 12, this is 13. We got three sides, one angle. The angle being unknown. So to me, when I'm in an exam, I go, well, that's a cosine rule question. So how do we figure? So the first thing is, let's use this formula. So A and B always have to be the two sides to make the angle. So this is your A, this is your B, and this is your C. It's always important that you write that, because it helps you substitute it in much more easily. So cos C equals A squared will be 12 squared, plus B squared, which is 13 squared, minus C squared, which is 10 squared, all over 2 times by A, which is 12, times by C, which is 13. And then what we get is all we have to do is just plug that into our calculators. But I'm just going to write it like this only because it's easier for me. You can just do that all in your calculator if you want. 24 times 13, I don't know what that is, but I'll just do that in my calculator. So 144 plus 169 minus 100 is 213. So that's 213 all over 24 times 13. It's 312. So we got cos C equals that. Then don't forget what you need to do now is that you need to bring the cos over, because you want to make C the subject. And if you want to bring the cos over, you got to do cos inverse. And the way you do that on your calculator is that you press shift cos. So shift cos 213 divided by 312. And then we have 46.95 degrees. So that's 46.95 degrees. Okay, so C equals 46.95 degrees. As I said, be very careful the way you choose your A and B. A and B are always the two sides that make the angle. Yeah. That's how you do these type of questions. I'll go through another one, and I'll show you how in the exam what they can do to make it a bit more difficult. So let's say you have, I don't want to draw the same type of triangle. Let's say you have something that looks something like, okay, so let's say that this is theta here, and then you have, this is 25 degrees, and then you have 10, 15, and then you have 17. Yeah, what they'll do is they'll just randomly include this 25 degrees to throw you off. Okay, if you got three sides and one angle, here you have three sides, two angles. Because you have three sides, two angles, technically you can use the sine rule or the cosine rule, right? Because you have more than enough information, because remember the sine rule minimum is that you need two sides, two angles, and the cosine rule information is that you need at least three sides and one angle. So here we qualify for both. But we here, because we're doing the cosine rule, I'm going to try use the cosine rule here. We are going to ignore this 25. Right? This 25 will not help us in doing the cosine rule, because if this is our unknown, this is going to be our A, this is going to be our B, this is going to be our C, and that's going to be the angle. So what we can say is that cos theta equals, now write the formula again, A squared plus B squared minus C squared over 2AB. Right? So we can say that cos theta is equals to A, which is 10 squared, B, which is 15 squared, minus C, which is 17 squared, over 2 times by 10 times by 15. So what we got to do now is just plug that into our calculators. 10 squared plus 15 squared minus 17 squared divided by 20. 20 times 15 is 300, which is 0.12. So we got cos theta equals 0.12. Then what we want to do is we want to shift cos it, because we want to get rid of theta's subject, and we get 83.11 degrees. So that's how we use the cosine rule. That 25 is useless to us. Now I'm also going to do this using the sine rule just to show you guys that it's going to give me the exact same answer. Now because I'm rounding, it'll probably give me something very, very close, but slightly different, maybe by a couple of decimal places. So we've got something with, so this 25 goes with this 15, and then we'll say that this theta goes with 17. So what we're going to do here is we're going to say sine theta over 17 is equals to sine 25 all over 15. So I'm going to show you here, my goal is to show you here is that it doesn't matter which formula you use, you'll get the same answer, as long as you know how to apply it. So this will be sine 25 all over 15 times by 17. Theta equals sine, so we're just going to, I'm not going to skip too many steps here. We're going to plug that into our calculators, sine 25 divided by 15 times by 17, and that's 0.47, and then we're going to press shift sign. We get 0.47896, 0.47896, dot, 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 and then I'm going to shift sign answer, which will be gives me a different answer. Interesting. Let's see, I must have made a mistake somewhere. Sine theta on 17 equals sine 25 on 15. Sine. Let me just double check this. Sine 25. So 0.12. What is going on here? 10 squared plus 15 squared. 83. Oh, right. Yeah, okay. Yeah, I know why. Okay, ignore this. The reason why this doesn't work is because the angle has to be a certain angle. Because I made these numbers up. Because I made these numbers up, this angle is predetermined. So it won't work. Just don't worry about it. But yeah, in an actual exam, they'll give you the correct angle for this, and it doesn't matter which way you do it, you will get the exact same answer. But that theta there, using the cos theta equals 0.12, is definitely going to give you the right answer. So just do that. But sometimes if they give you another angle, it's just used to throw you off. Don't worry about it too much, just ignore it. You don't need to use every single number when you're calculating something, especially because you guys are in advance. A lot of times they will try to throw you off. Yeah. So do we have any questions regarding using the cosine rule, or I think we're all good? Oh, one thing I do want to mention is that you always want to say that the angle that you're finding, so the C side, like one way that you can check is that the C side should always be opposite the angle that you're using. Yeah. So you can see that the C side is always opposite the angle that you're trying to find, right? If we go back and look at some of these, the C here is always opposite the angle. The C here is always opposite the angle. Yeah. So keep that in mind. So like the C will fall naturally if you choose your A and B correctly. A and B are always the two sides that make the angle. But yeah. So for homework, what I want you guys to do, so you guys have non-right angle trig book 2. Sam has sent that to you guys, I think a couple of weeks ago. You guys should be doing exercise not unit 4. You guys have redone 3-dimensional problems, graphs of trig ratios, obtuse angles, exact ratios, solve trigonometric equations. So unit 11, unit 12, unit 13, 11, 12, 13, 14, 14, 11 to 16. All right, so what you guys should be doing is you guys should be doing 11 to 16 for homework. I'll write it down here. So homework should be unit 11 to 16. Okay, so doing unit 11 to 16 should be your homework. All right, if you guys have any questions throughout the week, post it in the chat and I'll try and help you. If not me, Sam will be more than happy to help you. If I see it, I'll definitely try and reach out and see how I can help you. Or you guys can message me privately. I think most of you guys have me added already. So if you need help with any of the questions, just give me a buzz. So what I'm going to do before I wrap up the call, I'm going to send you guys this before we finish up. And I will stop the recording.